Hello, my friends. My name is Jessie, and this is Penny. And today on Science Will Save the World, we are going to explore the wonderful world of chemistry. So come along with us. We're going to do a really fun experiment. P.S. Something explodes. You don't want to miss this. So before we get started, there's a couple things I need you to understand about chemistry before I can explain what's going on in this experiment. The first thing is that everything in the universe, that's not just the world, but the whole universe, is made up of these teensy-tiny building blocks called atoms. And so atoms are so small you can't even see them under a normal microscope. You need a super expensive, super fancy scientific microscope to be able to see them. So I can't show you them. You're just going to have to take my word for it. So atoms are, you can think of them as like the Lego blocks that make up every single thing. So like I'm made up of atoms. You're made up of atoms. The trees outside are made up of atoms. The air we breathe, yep, it's atoms. All of that. So all they are is these Lego blocks that are sticking together to build the things that we are. You can think of yourself and you can think of me also as like a big fancy Lego castle. Cool? Awesome. The second thing that I want you to understand is that sometimes atoms just float along by themselves. Sometimes they cling together with their friends, like Lego blocks again, right? Sometimes a single atom or a couple of atoms stuck together can have an electric charge. And when they have an electric charge, we call them something different. We call them an ion. And so an electric charge just means they're either positive or negative, kind of like magnets. And so the positive and negative ions are pulled towards each other. They're attracted to each other. You still with me? Cool. So everything in the absolute universe is made up of these tiny Legos called atoms. I'm a Lego castle. I'm built of atoms, so are you. Sometimes these atoms have electrical charges, positive or negative, then we call them ions. You still with me? You cool? You cool? You with it? Okay, great. Let's go on. And so the next thing, what we're going to talk about today is about acids and bases. So you've probably heard these terms. Maybe you've even done an acid-base experiment. That's cool. We're going to talk about them first, and then we're going to go on to explain what's going on in this experiment. So acids and bases are special chemicals that have certain properties, and you've probably experienced these in your life. So for example, acids are things like you probably experienced vinegar is a pretty strong acid, lemon juice, orange juice, apple juice. All of these have that property of kind of being like a little sour, right? Like they're kind of tingly, which isn't to say that you should eat all acids. That's not a good idea. There's a lot of things we eat and a lot of things in nature too that are acidic. So a lot of plant chemicals are acidic. Your stomach makes acid. Maybe you've heard of stomach acid, and that's how it helps to digest your food. The other side is a base. So bases that you maybe experienced are, for instance, like if you ever helped your mom or dad make cookies and you tried some of the baking soda and it was kind of like how do you describe that thing? Like maybe a little bitter, right? Or maybe if you ever took like a bath or a shower and got like soapy water in your mouth, that's basic too. So chemically, how this works is acids are things that have a really lot of positively charged ions. So that's atoms with an electric charge floating around in them, okay? Bases, on the other hand, have a really lot of negatively charged ions floating around. So what do you predict might happen if we stick an acid and a base together? We're going to find out. Also, I'd like to say one thing. I'm going to explain this very simply at the beginning, but if you're interested, if you're curious about the chemistry of it, stick around after the experiment, and I'm going to do a little bit of a higher level explanation. So I'd say if you're like middle school or above, like hang out and we'll talk the chemistry of what we're about to do in a little bit. See you then. Okay, 4 things you will need today include, number 1, an acid. How about some vinegar? So I'm using white vinegar. If you don't have white vinegar, that's cool. Use whatever you got. Like apple cider vinegar, fine. Rice vinegar, fine. Whatever, as long as it says vinegar, use that. Thing number 2, a base. How about some baking soda? Thing number 3, a Ziploc baggie. I've helpfully labeled mine science. And thing number 4, a paper towel. Mine has lemons on it, but that's not required. Optional 5th ingredient, if you want, you might want to get some food coloring. I don't have any, otherwise I would make this look a lot cooler than I'm about to, but if you have some, it might be really cool. I suggest putting it in with the vinegar. Alright, so first thing you need to do is take your paper towel and you want it in a square. So I'm just going to rip mine, unscientifically, into a square, like that. Step 2, you are going to take your baking soda and you're going to put 2 tablespoons onto your paper towel. Here we go. 1, 2. It's okay if your measurements aren't exact. Now, you're going to fold that up into a little packet. Bloop, bloop. Just like that, and set it aside. Well, you might need to refold it later. Okay, next thing you do, you're going to grab your science bag and you're going to get some water. I forgot to say you need water. Here it is. You're going to measure 3/4 of a cup of water. Carefully, carefully, carefully! It's okay if you spill it and clean it up later. And you're going to put it carefully into your baggie. Cool? Then you're going to take a 1/2 cup of vinegar. Here's your vinegar. Bloop. And you're going to pour that also into your bag. Carefully, 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 carefully. 1/2 cup. Here we go. 1/2 cup of vinegar. 3/4 of a cup of water. It's okay if you sploosh a little extra if you're not sure about your measurements. Sploosh. Okay. Now I have my packet of baking soda and I have my baggie of vinegar and water solution. Do not combine them inside unless you have maybe in your sink or maybe in a bucket or something, maybe the tub. But I think it's probably for the best if we go outside to do this next bit. You'll see why. So once again, I didn't have any food coloring to add to my vinegar, but it probably would have looked a lot cooler if I had. Once you get to a good outdoor space, open up your bag, suspend the baking soda packet over the vinegar inside without dropping it yet. You're going to carefully zip it with your other hand, and at the last minute, drop that packet in, zip it shut, shake it up, and get out of there. Let science do its thing. And I'm going to pause it right about here. And now I'm going to speed up the video to make this go a little faster. It actually took over 3 minutes for the entire reaction to progress in my case, and actually I had to run in at the end and give it a little extra shake. So if it seems like your reaction isn't happening as fast as you'd like, maybe, but it gets to this point where the bag looks like it's about to explode and nothing's happening, maybe send in your resident grown-up to give it a good shake and then have them get out of there, because sometimes that's just what it needs. One little extra push. And here I'm coming real fast. Get in there, Jesse. Ugh, sweet release. So what on earth just happened? Let me give you the simple explanation first. So what we did outside was we combined an acid, vinegar, with a base, baking soda, and something happened. That bag inflated, and if you were lucky, it exploded. Although, if I'm being honest, it took me like 4 or 5 tries to make it explode the way I wanted. So what this was a chemical reaction. And a chemical reaction just means when you combine 2 or more things and they turn into something else. So you can think of it in our Lego example. It's kind of like if I had like a little Lego house and then like a little Lego boat, and I took all the Legos apart and made them into something new. That's kind of like a chemical reaction. And the exact kind we had, we used the acid vinegar, and we use the base baking soda. And when we combine these two things, there are a couple of things that happen, but the most noticeable result was that gas. I think you saw how that bag started to inflate, right? Something in reacting these two substances was causing it to inflate. And what was happening was it produced this gas called carbon dioxide, which, everybody take a deep exhale. Like, that's carbon dioxide. It's also the thing that you exhale. So that's the very simple explanation of what happened. Let's get into the higher level thing if you want to stick around. I felt like this explanation required a lab coat. I'm ready. Are you ready? Wait, now I'm ready. Okay. Let's get into the chemistry of what's really going on here. So I gave you the more simplistic explanation of how we reacted a acid and a base. We had a chemical reaction and it created something new. And I even went so far as to say it was carbon dioxide. That isn't untrue, but it's a little more complex than that. So I assume you're here because you want to hear the deep, dirty secrets of the chemical reaction, and I'm here to tell you about it. If you want to go so far as to actually see the equation, I'll put it in the description of the video. So chemistry geeks, I am here for you. Okay, so let's get into it. So I've already explained that we had vinegar and baking soda. These have scientific names as well. So the chemical name for this, vinegar, is actually acetic acid dissolved in water. So we'll call this acetic acid is the name of vinegar. Baking soda, on the other hand, is sodium bicarbonate. So acetic acid, sodium bicarbonate. Okay, cool. So when we react these two things, it's actually a two-part reaction. So, and it happens too fast for you to even know, because the first thing happens and the second thing happens so quickly that you only see the end result. So the first thing that happens, step one, acetic acid reacts with sodium bicarbonate and it produces two things. One of those things is sodium acetate. We're going to sort of not worry about that thing. It's a salt. Time out. And by salt, I don't mean salt like you would put on your food. Please never put anything you make in chemistry on your food. Never. A salt is just the name for when those electrically charged particles, the ions, when they interact, then they form something stable. And we call that a salt in chemistry. Okay. We're back. Okay. So that sodium acetate is a salt that it creates. It also has another result, carbonic acid. Okay, acetic acid, sodium bicarbonate, step one, we have sodium acetate and carbonic acid. That carbonic acid that's created in phase two of the reaction, carbonic acid is also an acid, so it has a lot of those extra positive ions, but it's also really unstable, so it just falls right apart. Okay, so it immediately falls apart into water, H2O, and carbon dioxide, as I mentioned, which is CO2. It's again the thing we exhale. Whew. So the three end products of this whole reaction are sodium acetate, water, and CO2 gas. And so what happens, the reason you see that bag inflate is because the CO2 is being released from the water, from the liquid solution, and it's bubbling and bubbling, and we have it in a closed system of that bag. So it just inflates, inflates, inflates until it can't do it anymore, and then poof, that's why I wear the goggles. Yeah. So that's sort of the down and dirty what's going on in chemistry. I hope you enjoyed our brief foray into chemistry for today. If you'd like to see more things like this, let me know. I have a lot of things planned, but we'll see. Also, I hope this has opened your eyes to the big wide world of chemistry jokes. Here's my favorite one, and I'm not even going to explain it. I'm going to make you look it up. Johnny was a chemist's son, but Johnny is no more, because what he thought was H2O was H2SO4. So look that up. I'm not going to explain it. And I will see you nerds next time. Thanks for coming. Bye.